what's a circle? And how do we talk about a circle in terms of the Cartesian grid, right? How do we describe a circle in terms of x's and y's, which is what a Cartesian grid is made up, right? So we have like a point on the Cartesian grid, and we give it a coordinate, an x and a y, and that way we can find that point with precision. Now what if we have more than one coordinate on the Cartesian grid? We'll have another coordinate, and we could just keep our x's and y and call it y2. So I'm just kind of explaining the language of the Cartesian grid. Now in terms of finding an equation for a circle, the circle has a whole nother, like geometrically speaking, another language to it, right? Another way of talking about it, which uses r and c, circumference, radius, and it has certain restraints. One of the restraints is that the radius is a set of all of these points are all equidistant from the center. So there's a center and there's a set of points around it that are all the same distance from that point. So if you set up that cookbook, if you set up that set of ingredients and that recipe, you're always going to get a circle. Just some amount of points, an infinite amount of points around a center. So in order to describe a circle in terms of x's and y's, right, like how would you do that? How would you give an equation in terms of x and y's? It's best to go at that through understanding the distance formula. So I'm going to help us understand the distance formula intuitively. All the distance formula is a description, right, a mathematical description in terms of x's and y's that tells us this distance, d, between 2 points, say point 1 and point 2. So the best way to talk about that is using Pythagoras. The Pythagorean theorem says that a squared plus b squared equals c squared. So what we're going to do is we're going to lay this concept, the triangle, onto the Cartesian grid. We're going to translate all these terms, these variables, a, b, and c, into x's and y's and d. So if we were going to transpose that shape, this imaginary triangle, onto the Cartesian grid, we can already see c is equal to d. D is the hypotenuse in this case. So how are we going to describe a? What is a? What is the length of a? So the easiest way to do it is extend your lines down to your axes. Right? So what does a become if this is a and this is b? Well, a is this distance on your x-axis, and b, right, is the other side of this imaginary rectangle, is this distance. So we have to give these 2 points names. So let's call this point 2 and this point 1. So what is point 2 equal to in terms of the x and y coordinates? Let's give it a name. So let's call it x2 comma y2. And let's call point 1 x1 comma y1. So this becomes x2, x1, y1, y2. So we're just translating our x and y coordinates across the plane. So now we can rewrite the Pythagorean theorem in terms of the coordinate system. So a is the difference between x2 and x1. And we're going to square it. B is the difference between, this is our b, right? y2 and y1. and C is D. So now we have completely rewritten in another language, really. We're still in math, but it's basically like translating from one language to another so that we can talk about a shape algebraically. And this is a beautiful concept in mathematics. Now, to complete the formula, we often see it expressed as the square root, so that D is on its own, the D term. Okay, so now what I would like to do is take what we have just learned and apply it to a circle. It's basically the same idea. So we're going to take a circle and all of its terms, and we're going to apply that to the Cartesian grid. So a circle has a center. So we have to give the center a name. We have to give it a coordinate if we're going to draw a circle, describe a circle in the geometric plane. So let's call the center, let's call it h comma k. Those are just two coordinates. They're two variables on the x and y axis, h and k. And these are the conventions. It could be anything. So this is our x-axis. So there's some number, h on the x-axis. So the center of the circle is equal to h comma k. Now, what is the definition of a circle? It's all of the points that are equidistant from the center. That's the restraint. That's what describes a circle. If there was a point out here, if there was some series of points out here, then the circle would become some kind of odd shape, right? Which could be cool, but that's not the definition of the circle as we know it. So all the points have to be equidistant from the center in order for it to fit the definition of a circle. So we have a distance formula here that we just came up with. So if we think about this as d, right, by way of Pythagoras, then we know that this distance is equal to x2 minus x1, y2 minus y1. But if we remember from our previous drawing, what is this point? That's point 1, right? Point 1. And we're going to call that h comma k. So the equation that shows, that reveals, that describes all of the points that are a distance d from h comma k is what? Well, all we have to do is replace our point number 1 with the variables hk, with our language of the circle. So we end up with the square root of x2 minus h squared plus y2 minus k squared equals d. But what is d? D is r. So this process of relating one language to another and translating comes up throughout mathematics. And it's basically we just keep dressing up things in new languages in order to make sense of them and understand what they mean. So this is your equation of a circle. And I just want to point out how subtle it is. If we choose, let's say we want to make a circle. Let's choose where it's going to be. So we're going to pin down somewhere in space where the circle is going to be. Then we know what h and k is. Let's say the circle is going to be in wherever, in some place, in some town on the map. Then x and y has to satisfy. All the x's and y's must equal whatever size circle we want. Let's say we want a really big circle. Let's say we want a radius of 2,000 feet. Then any x and y must work in this equation, right? It's like a puzzle. It all fits together. And then you can work in the reverse. You can decide that the h and k can move and the radius won't move, and it can become flexible.